All right, let's get started. We're supposed to write an algorithm that takes an array and moves all of the zeros to the end. But we have to preserve the order of other elements. Pretty straightforward. Okay, so I'll just paste in PDoc and get started. So they say that it's an array, so we can start thinking about inputs and outputs here. So it's an array. That could potentially be an empty array, could potentially be a sparse array. Although that's rather unlikely given that this is Codewars. They give us one example here that contains some elements that are not numbers. So like many different types. So yeah, empty array, sparse array, or normal, populated array, populated. Okay. And then elements, seemingly they can be any type, right? So other than number. There's also, the possibility of infinity, not a number, negative infinity, various other types of numbers, but all we really care about, and what I can tell, is whether or not it's a zero. So that's a fairly easy situation to deal with. So if I were to summarize this problem, we essentially just want to transform the input array of elements into an array of elements where where all the zeros have been moved to the end of the array. Okay, cool. Okay. And as far as our output, it's just, I guess the question would be, are we supposed to mutate the input array? Or do we want to return a new array without mutating input? That'd be a question for the interviewer, I suppose. And the big thing here is that, like on top of all the zeros being at the end of the array, we also need to ensure that the overall position of all the elements that are non-zero remains unchanged. Okay. So I think it makes sense to probably, I think generally you should avoid mutation. So that's what we're going to do. We're going to avoid mutation. Okay. And yeah, let's think about an example here. So we can just walk through this one. Why not? So we'll have this fresh array, right? And as we're traversing the elements contained in this array, so first element, Boolean false, we can just push that into our, what this will be is the result array, the one that we want to return out of our function. So we're going to be traversing the input. False is not 0, 1 is not 0, so we can push that into there. Now we find the 0, right? So we actually want to splice it out or remove it from the array entirely. And really, we could do this a lot of different ways. One thought might just be like the splice method, where we would, we're thinking this, we don't want to mutate, and splice is mutating. So we could I guess one option would be to just increment some counter every time we encounter a 0, and then at the end we could just pass. We could concatenate two arrays together with the amount of zeros, right, that we have encountered throughout this. So if we were to take that approach, we just have some variable, and every time we encounter a 0, we just increment the variable by 1. So 0's variable would now be 1, and so on. And as we're doing this, if they're not a 0, we would just add them to the result array. And so we encounter another 0, and increment zeros, then adding 1, 2, a, well, sorry, 1, 3a. Okay, and then once we get there, our total count for zeros would just be 2. So we would essentially just want to concat zeros, zeros. So that many zeros to the end of the array. So that's like one approach. Another one would be to actually mutate the array, and we could do that with splice, where we could essentially just traverse the array from left to right, and every time we encounter a 0, we could splice it out. And I suppose you would probably, would you decrement I? I think you would decrement I as you go, because like say if we were to take that approach, let's grab another one of these examples, right? So if we were to take the approach of splicing, so we'll just document our code here. Say we are encountering this element, so it's a 0, so it means we want to do something. So we'd essentially be splicing from whatever the current index is, and at this point it would be index 2. So we want to splice from 2, deleting one element, and then not replacing it with anything. And so typically, as we go to our next, so essentially what it would look like, right, would just be this now, and we would have captured that 0, and we would likely want to push it onto the end of the array, so it would look like that. But then we would be on to the next element, and that actually might be fine. We might not have to decrement I, because then it would just be at index 3. So yeah, that could probably work. Those are two approaches. So the one where we are just incrementing a zeros counter, or splicing out elements, then adding them to the end. So we could do a combination too. If we wanted to like do something where we would like stop after we like say we take the approach of splice and we get to this next element. Okay, 0 is now gone and it's pushed to the end of the array, and then we continue throughout. And I think we would need to have like some sort of counter, because we don't want to having to be dealing with all the zeros at the end, right? We just that's how it's supposed to look. So I think we could combine our approaches. We could have like maybe some operations count or splice count, and then once we reach the element, so say we have this length, right, of the input, and what is that, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it has a length of 9. There's 9 elements, so maybe like 9 minus splice count, that would give us 7. So I guess once we get to the and this should be 0 index, so it would really be 8, right? If we're dealing with indexes here. So this would be 6. Okay, and then once we reach the index of 6, so 0, 1, 2, 3, 4, 5, 6. Once we get here, we don't really care about what's to the right of this, because we know that it's only ever going to be zeros. So that's one approach. I think it's a little bit more verbose than the other. Well, I mean, it's an optimization to the splice method, or the splice approach, which I'm actually not a huge fan of anyway. I think I like this approach a little bit better. So I think that's what I'm going to do. So comment this stuff out and get started with our pseudocode. Okay, so let's make this a little bigger for you guys. First thing we want to do is probably guard for empty arrays. Okay, and then I guess a question here, if I was in an interview, I would have to ask about how we should handle sparse arrays. So like in an example, like say we have an array that looks like this, like maybe A2, 0 or something. Something like that. And then we made it sparse, right? So like 10 or something. How would we deal with an array like this? Because it would be of length 10, and it would have, I think, just 6 empty slots or empty spaces in it, which I guess you'd have to ask, like, okay, do we actually want to have those elements? So technically there's nothing there, but if we try to access the element of an area in an array which is sparse, it would just return undefined. That doesn't mean that it's explicitly undefined at that index, but that's just something we would have to clarify with the interviewer. So I think for our purposes, we're going to not worry about sparse arrays. So just empty arrays, or literally just empty arrays. Okay. And then we want to, we're choosing to avoid mutation. So we're going to declare empty array. So this is result. Okay. And we basically just want to traverse the input array, the elements in the input array. So traverse input arrays elements, input array, and for each element, check if it is 0. If it is 0, then we want to increment our counter zeros, which we forgot to declare. Declare zeros. Okay. So we're traversing our input array. We're checking each element to see if it's 0. And we want to increment zeros. If it's not 0, then we just want to push current element into result array. Okay. And what are we calling input? Just array. I'm gonna change it to input. Okay. So once we're here, once we loop through our entire input array, then we want to essentially check to see how many zeros there were, and then add that amount of zeros to the end of the array. And we can do that in a couple of ways. One would just be to literally just use like a loop or something and just add, like just push zeros into the end of our result array. Another way would be to fill an array. So using the fill method, I think it's array fill. I'm honestly not super clear on the syntax, but I know that as long as you're using primitives, you usually get behavior that you're looking for. So I think I'll probably for now just go with the approach of looping this many times and then pushing zeros into our result array. It's a pretty straightforward approach. So yeah. Sorry. Skiing today. Okay, so basically just while zeros is greater than 0, we want to do something. And what we want to do is push 0 into the result array. Okay. And then we would want to also decrement zeros by 1 every time. Okay, and then once we're done, we just want to return that result array. So if we were to just walk through an example here, where's the initial? Yeah, this is the initial test case. So I'll just paste this up here, and then this is going to be a stand-in for our result array. So we're guarding, it's not empty. We're declaring some variables, initializing them to some values. Then we want to traverse these elements. So we'll just get started on that. False is not 0. So we want to push false into result. The next element, so then we're iterating, is 1 is not 0. So we're pushing 1 into result. Moving to the next index, we encounter a 0. So what do we do? Well, if we look at our algorithm, we just want to increment zeros. So now zeros is actually 1, and then we iterate. If we move here, it's a 1, so we can push that on to or into our result array. And I'm gonna speed this up because I don't want to be here all night, and I'm sure you guys don't either. So we encounter that second 0, and then 1, 2, 3a, all added. Okay, and now we're done traversing our input array. So now we reach line 36, and we're encountering this block of code. So essentially, while zeros is greater than 0, we want to push 0 into result. So that's just going to iterate twice, because zeros is 2. So decrement 1 and adding a 0, and then decrementing again, or adding a 0, and then decrementing. And then this is now back to 0. So now zeros is not greater than 0. 0 is not greater than 0. Then we exit this while loop and then just return this result array, which is what we're looking for. So yeah, in like a normal interview, I would come up with a lot more test cases, but yeah, I'm just trying to do a short one today. So cool. All right, so let's write some code. Okay, here we go. We can just move maybe this up to the top. Okay. So make this a little bigger. All right, so here's our algorithm. So let's just get started writing our code. So the first thing is guarding for empty arrays. Return, what should we return for an empty array? It should just be empty, I would guess. Okay, then we want to declare result empty array. Okay. And then we want to declare zeros. So that's the initial value for that variable. And let's move this up. Okay, so now we want to traverse our input array, and we're going to use just a normal for each for this operation. So if the element is equal to 0, we just want to increment zeros by 1. And I'll do the more verbose version. Okay. And if it's not 0, then we want to push current element into result. So this is actually a great place for a ternary. So that's what we're going to do. Okay. That's all that's going on in that for loop. So now that we've looped through input, we now want to add the zeros to the end of result. So our pseudocode says while zeros is greater than 0, do something, and that something is pushing zeros into result and decrementing zeros by 1. So that's what we'll do. Okay. And finally, we just want to return result. Oh, and it's, yeah. Okay. So we feel good about this algorithm. and let's just take a run and see how we did. Okay, we passed one test case. Let's check the other ones. Okay, we passed them. So, yeah, this was a fun problem. Just kind of, a practice for me. Getting back in the swing of things. I've kind of been taking a break. So, yeah, thanks for watching. I'm gonna call it. Peace.